Welcome to this explainer. Today, we're unpacking the hidden embryological timeline of the umbilical cord. You know, for something that literally every single one of us has, the sheer complexity of how it develops is almost never talked about. Well, we're going to change that right now. Okay, let's dive into this timeline. We'll start with the ultimate fetal connection, march week by week from weeks 2 to 4, check out a really bizarre but totally normal event at week 6, take a look inside the cord itself, and finally see what happens to all this architecture after birth. Let's kick things off with section 1, the ultimate fetal connection. Now, what's actually fascinating here is the counterintuitive blood flow. If you think back to standard biology, right, we usually associate arteries with oxygen-rich blood and veins with oxygen-poor blood. But in the umbilical cord, it's completely flipped. You've got these two small umbilical arteries, and their job is to pump deoxygenated blood and CO2 away from the fetus to the placenta. On the flip side, the single, large umbilical vein is doing the heavy lifting, bringing fresh oxygenated blood and glucose straight back into the developing fetal heart. Okay, section 2, let's look at how this lifeline is actually built, starting from weeks 2 to 4. We're going to use this developmental timeline to anchor us. We'll trace the rapid, almost simultaneous changes happening in the womb from week 2 all the way to birth, watching this incredible structure piece itself together. To make sense of all this complexity, I want you to think of these 3 specific parts as the ultimate structural recipe for the umbilical cord. It all boils down to 3 core components that show up sequentially. First, the body stalk. Second, the vitelline duct. And third, the allantois. Seriously, keep these 3 in the back of your mind as we go through the next few weeks. So, it's week 2. Right now, the embryo is basically just a flat, 2-layered bilaminar disc. But outside of this embryo, cells are rapidly differentiating into a layer called the extraembryonic mesoderm. These cells line the outer space to form the chorion. The big takeaway for us here is that the embryo connects to this outer chorion via a short band of tissue. That band, that's the body stalk, our very first core structure. Then, by week 3, things literally start folding into place. The flat embryo folds longitudinally, both cranially toward the head and caudally toward the tail. It's an amazing transformation that takes it from a flat pancake shape into something that looks a lot like a tiny little shrimp. And this folding is an absolute game changer because it shapes part of the yolk sac into a gut tube, which then divides into the foregut, midgut, and hindgut. This is exactly where our next 2 structures make their entrance. The midgut stays connected to the yolk sac through the vitelline duct, so that's structure number 2. And right around the exact same time, the hindgut grows this tiny pouch that stretches out toward the umbilical cord to drain the developing bladder. That is the allantois, our third and final structure. Moving into week 4, the cells lining the amniotic cavity start churning out amniotic fluid. The cavity swells up dramatically, expanding literally like a giant bubble. And as it expands, it folds down and around the embryo, physically pushing those 3 totally separate structures, the body stalk, the vitelline duct, and the allantois, tightly together. They're forced out of the fetal abdomen through a fibrous ring called the umbilical ring, and they get wrapped up in this brand new outer membrane formed by the amniotic bubble. And just like that, the umbilical cord is officially formed. All right, section 3, the week 6 herniation, because the story definitely doesn't end there. The phrase umbilical herniation probably sounds a bit alarming, but the key word here is physiological, meaning it is a completely normal, expected part of development. Around week 6, the fetal intestines are just growing at an explosive rate, so fast that they literally run out of room in the tiny fetal abdomen. So what do? A section of the intestine actually squeezes right through the umbilical ring and out into the umbilical cord itself. No way, right? But don't worry, it's just a temporary vacation. By the end of the 3rd month, the intestines pack up and safely withdraw completely back into the abdominal cavity. Let's move to section 4. Inside the umbilical cord. Now that it's fully built, let's take a cross-section and look inside. When you slice it open, you reveal a beautifully organized system. On the very outside, you've got that protective layer of amnion we talked about. Inside, you'll spot the vitelline duct with its vessels and the yolk sac. You'll see the allantois. And of course, you've got the primary circulatory pathways. Those 2 small umbilical arteries and the single, large umbilical vein. But here's the thing. These fragile structures aren't just loosely rattling around inside an empty tube. Everything in there is suspended in a highly specialized, thick, gelatinous substance called Wharton's jelly. This jelly is absolutely crucial. It provides structural support and acts as a heavy-duty cushion, preventing the vital umbilical vessels from getting kinked or compressed while the fetus is busy doing gymnastics in there. So, Section 5, Life After Birth. What happens to all of this once the baby arrives? Once the baby is born, the cord is cut, leaving behind the navel, or the belly button. But the internal structures? They undergo a brilliant biological recycling process. The umbilical vein eventually transforms into the round ligament of the liver. The two umbilical arteries become the medial umbilical ligaments, and the allantois, which was called the urachus in the fetus, gets renamed as the median umbilical ligament. Now, if you're trying to keep all that straight for a test or just your own memory, those ligament names sound incredibly similar. But here's a super helpful mnemonic. Just remember that the two umbilical arteries become the medial ligaments. Notice they both have the letters A and L. On the other hand, there is only one allantois, so it turns into the median ligament. They both end in the letter N. It's a really simple trick, but it absolutely hits the nail on the head for keeping this anatomy straight. And what about the vitelline duct? Well, normally it just shrinks and regresses completely until it's gone. But in some rare cases, it refuses to disappear entirely. It leaves behind a tiny intestinal remnant, a small pouch of the midgut known clinically as a Meckel's diverticulum. It's just a fascinating, tiny architectural leftover from our earliest weeks of life. So, if there is one crucial thing to take away from this entire explainer, it is the number 3. This entire complex lifeline that sustains fetal development is built upon just 3 original embryonic structures: the body stalk, the vitelline duct, and the allantois. Through this miraculous process of folding, expanding, and even that crazy temporary herniation, these 3 elements combine to literally tie us to life. It really leaves you wondering about the hidden history written right into our anatomy, doesn't it? What we usually just dismiss as a simple scar on our stomach is actually the fossil of an incredibly complex, highly choreographed biological journey. Thank you so much for joining me on this explainer. Keep looking closely at the world and your own biology, and I'll catch you next time.